from the sun hits the water and diffracts into RGB, red, green, blue, all the colors of the rainbow, which results in diffraction. Basically, the light hits the water particles and basically disperses into the different colors that we can see. And we reflect back to our eyes as a rainbow, when actually they're all visible light.
And on the RGB scale, well, we're missing indigo, but purple is purple. So red has the longest wavelength and the lowest frequency, while purple, or violet, has the highest frequency and the shortest wavelength.
The three primary colors of light are blue, red, and green, which all make white. The combination of these three make pigments. These pigments right here: cyan, magenta, and yellow. The combination of these three make black.
Another cool thing about light is that, as you can see, there's multiple colors of light. The cool thing is the higher the frequency, the faster it gets to your eye. There's a reason why fire trucks are turning more yellow, because you see yellow faster than you see red. So red fire trucks turning yellow fire trucks because you see yellow faster. That's why majority of construction vehicles and majority of caution symbols are all yellow, because you'll see it faster and be able to understand it faster. And your brain interprets yellow as a danger caution symbol now. Another cool thing about light is that light absorbs and reflects. See a white shirt? A white shirt reflects white light into your eyes. It absorbs all the other colors. While a black shorts, like I'm wearing right now, reflects none of the light, so it looks black. Alright, another cool thing the light does, when the light hits a mirror or a flat surface of glass, it reflects. Basically, the light bounces off it while also staying in the image. It's gonna be effective with plane mirrors and so on and so on. Alright, another cool thing about light is that it reflects, which is why our license plate reflects light. Basically, the material is made to where when light hits it, it reflects back easily to you. So at night, if a cop wants to spot your license plate, they can easily do it. Or if you're trying to make sure you don't get run over, like a reflection in the back of your bicycle.
Alright, this is a concave light. It's usually used for builders, so whenever they're building, the light spreads out instead of going inwards and more focused. It spreads out that way. They'll be able to see everything whenever they're working.
So on a car, there are convex mirrors, which means that the light being projected will go forwards so other cars can see it. So as you see, because it goes outward, not inward, as a concave mirror would, this is a convex. So it means the light will project itself towards the other drivers on the road.
Another fascinating thing about light is something called internal light reflection. Basically, when light goes inside the water, it bounces backwards and forwards like a tunnel. Like a bounce about going down a tunnel. That's basically why if you ever see a fountain, they always have a light underneath the water, because the water will travel through the fountain water. That's why fountains are able to get colorful colors and make streams of light and water together, because of internal light reflection. The internet is a creation from internal light reflection. Basically, we send a light down a fiber optic cable to another computer, which transfers the lights decrypts it and puts it on your monitor. And so internal light reflection actually created the internet. Alright, another extraordinary thing about light is whenever a light passes to a new medium, such as water and air, it changes speed as well as direction due to diffraction when it hits another medium. As you can see, the light moving backwards and forwards. Another cool thing that happens is, if you have a full light, if you have two objects right here and you have a light going this way, it will actually hit both ways, but then actually go around. And something that we'll call interference will happen, which proves that light is a wave. And another amazing thing about light is something called solar energy. And us humans have made a scientific discovery with the power of solar energy. We've made solar panels, which is clean, renewable, usable energy from light, because light is energy. light is also a wave slash a particle. It acts like a wave and moves like a particle, which has baffled scientists like Albert Einstein and Boris Nohr. It's just it's a phenomenon and a paradox at the same time.
Okay, so light is also very interesting as well because it acts as a particle and a wave, which is very uncommon. So when we use it for reflecting light, it acts like a particle. And when we're using it for like EM spectrum, it actually acts as a wave.
Light is an ultimate tool of society. Not only did it help us build the internet or help us conquer the dark as cavemen with fire and light, but also it has helped us grow plants. Light also helps us see what we cannot see. Light helps us send information across countries and continents into even outer space and the moon. Light is one of the most important things about light, so it's very crucial that we understand the physics behind it